Hello everyone, welcome to this video. In this video we have to show that this term is equal to 3n plus 5 divided by 3n plus 1. So let's start by taking this left hand side. So let's take this left hand side over here. Now what you can do, you can see in the numerator it is the sum of various terms. So you can write down this term separately and this term separately. Here what is the nth term in the numerator? You see your nth term an is this one, n into n plus 1 whole square, and in the denominator your nth term is n square into n plus 1. So therefore you can write whole of this term into summation a k divided by summation a k, where this k varies from 1 to n and here also k varies from 1 to n. If you wanted to differentiate them, you can write it as ak1, here k1, and this is ak2, this is k2, correct? To denote that these two are different terms. Okay. Now you can substitute the values here. The nth term could be k into k plus 1 whole square, and in the denominator it is k square into k plus 1. Right? Now next what you can do, you can open up the terms. You can open up the square. So k square plus 1 plus 2k, right, into k. So it would be k cube plus 2k square plus k, and then you can separate out the summation. And similarly in the denominator it is k square into k plus 1. So it is k cube plus k square, right? K square plus k cube. You can separate out the summation on both the terms, and then you can use the formula for the cube of first n natural numbers, the square of first n natural numbers, and the sum of first n natural numbers itself. So this is the formula for cube. We have n plus 1 divided by 2 whole square. For the formula of square, it is this term. And for the sum of first n natural numbers, this is this term. Similarly for cube we have this formula, and for square we have this formula. Now beware that some of you might say we can cancel this with this term, or we can cancel this with this term. This is entirely wrong. We cannot do that until and unless we have a plus sign in between, right? So notice that thing in mind. Once you have these terms, what we can do, we can simplify it. How we can simplify it? Notice that here within this expression you have n plus 1 divided by 2 in each of the term, n plus 1 divided by 2, n plus 1 divided by 2. Here also n plus 1 divided by 2, n plus 1 divided by 2. So you can take it common in both numerator as well as in denominator. So in the numerator you can clearly see you have, when you take n plus 1 by 2 common, so you will be left with, because we have square term, so 1 power is left behind. Here we are left with 2n plus 1 divided by 3, right? Everything else is taken outside, and this 2 also. And here everything has been taken outside, so we are left with plus 1. Similarly in the numerator, we can, once we take n plus 1 by 2 common, we are left with 1 power of it here, like this. And you have taken this outside, and 2 into 3 this outside, so you're left with 2n plus 1 divided by 3, right, this term. Once you have this term with you, so you see both these terms gets cancelled, so you're left with this much portion. So here you can simplify the terms. You can take 6 as the LCM, take it outside, so it would become 3n into n plus 1, which you can solve, right? Here it would become into 2 into 2 into 2n plus 1, which would be 8n plus 4, and here it would be 1 into 6, which would be 6 after taking the LCM. Similarly here also you can take the LCM 6, so it would be 3 into this term, 3n square plus 3n, and here it would be multiplied with 2, so it would be 2 into 2n plus 1, which is 4n plus 2. So you see this and this also cancels with each other, both 1 by 6 and 1 by 6. So you are left with 3n square plus 11n plus 10, right, this term, and 3n square plus 7n plus 2, this term. Now what you can do, you can factorize both of them. To factorize, you know how to factorize. We obtain the factors as 3n plus 5, n plus 2, and 3n plus 1, n plus 2. So this n plus 2 and this n plus 2 gets cancelled with each other, so you're left with 3n plus 5 divided by 3n plus 1. And what is it? It is your right hand side, and this is what we wanted to prove here in this particular video. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.